Okay, let's jump right in. Today we're doing a deep dive into a really specific piece of tech, the DVIGear Hyperlight DVI-2540 AOC. We've got the spec sheet right here. And the big claim is that these cables shatter limitations for long-distance video. So let's start there. What is the fundamental problem that this is engineered to solve?
Right. Well, the core problem is really just physics. You're trying to push these massive, ultra-high bandwidth HDMI signals way past the point where a normal copper cable just, gives up. We're looking at a cable that promises 18 Gbps total data rate.
So that's full HDMI 2.0.
Exactly. Full compliance, which you absolutely need for uncompressed 4K video at 60 frames a second. And of course, it handles all the HDCP content protection, both new and old.
Right, because with copper, you start seeing serious signal degradation, around 50 feet or so when you're pushing that much data?
Oh, easily. And this cable, it goes up to 100 meters. That's 328 feet.
So that distance, what are we really talking about, signal quality-wise? Is there compression?
None. It's flawless. You get 4K 60p with no artifacts. It supports high color depths like 4.4.4 8-bit or even 4.2.2 10-bit. The pixel clock is running at a max of 600 megahertz. The only way you can maintain that kind of fidelity over that distance is to, well, change the medium entirely.
Okay, so how does it do it? What's the secret sauce that beats that signal loss?
It's the optical engine. The actual video transmission is handled by 4 discrete optical channels. They're running at a really high frequency, 850 nanometers.
Light, not electricity.
Exactly. That light engine is what just completely sidesteps the degradation you get with copper. And what's really interesting here is the power side of it. It draws such little power, less than 50 milliamps, that it just pulls it right from the HDMI source itself.
So no power injector, no extra wall wart.
You skip that whole cumbersome external power supply. It's a huge convenience.
Okay, so the optical engine is the performance winner. But performance is one thing. If you're an installer pulling 100 meters of this through a plenum ceiling, it has to actually survive the job. The design is a hybrid, right? 4 optical fibers and 6 copper wires. If the video is optical, what's the copper for?
Yeah, that's a great question. The copper is there for the essential control signals. That includes the tiny bit of power needed for the optical chips at each end, but also, critically, the DDC lines.
The DDC lines. That's the handshake between the source and the display.
It carries the ED data and the HDCP communications. That's how your Blu-ray player and your projector actually talk to each other and agree on a secure connection, so you need both.
Got it. Let's pivot a little to the cable's sort of immune system. Since the video is carried on light, does that build in a kind of electronic shield?
It absolutely does. Because it's primarily optical, it has a very, very low RFI EMI profile.
Radio frequency and electromagnetic interference.
Right. And why that's critical is this cable is designed for mission-critical applications. Think medical imaging, military simulations, broadcast, places where you absolutely cannot risk the cable emitting noise or having its signal disrupted by outside noise. It's just incredibly discreet and reliable.
And for the installer on a ladder, installation costs and time are always the biggest headaches. It's plenum rated, which is great. But what else makes a long pull easier?
It's all in the mechanical details. They've really thought about this. That tiny minimum bend radius, just 2 millimeters, is an installer's best friend when you're going around a tight corner.
2 millimeters? Seriously?
Yeah, it's incredibly flexible. But the real game changer is the 2 removable HDMI docking connectors. You can take them off, which shrinks the cable's cross-section down to just 12.4 by 10 millimeters.
Ah, so you're pulling a much smaller head through the conduit.
A much smaller profile. It makes it way easier to pull through narrow pipes, and it really minimizes the risk of snapping off the connector head during a tough pull.
So wrapping this up, the key takeaway for you, the listener, is that this Hyperlight series really does seem to be that engineering bridge. It gets you past the physical limits of copper for professional high-demand 4K 60p setups, its performance, but also durability and electronic silence.
And if we sort of connect this to the bigger picture, the unique achievement here isn't just sending video 100 meters. It's that it maintains all those complex live DDC communications, the handshaking, the copy protection, all with that super low RFIME profile. And that raises a really important question for the future. So I'll leave you with this.
What do you think is the next complex, large-scale AV system that's going to demand this exact level of discrete long-haul performance?